Now that we've talked about how to find the value of the slope of the tangent line, the value of the first derivative, it makes sense to talk a little about the meaning of this, why it might actually be important to find this. So of course, if we're just talking about a function in the abstract, and when we find the first derivative, what we're finding is the slope of the tangent line if we needed to find the tangent line at a particular point. And as we'll see, this gives us extraordinary insight into the geometry of a function. That's what we'll be exploring in the next few chapters. But if what we're talking about is anything with applications, then the first derivative we can view it as an instantaneous rate of change. So for example, suppose we have a position versus time graph. Well, as we know in a position versus time graph, if we take the slope of a secant line, that gives us something called the average velocity. But if I can find the slope of the tangent line, that would be something known in physics as the instantaneous velocity, the velocity of an object at a particular point in time. And it turns out that that is often something quite valuable to know, especially if you're calculating air friction or something like that. It has enormous applications in physics. Another example is suppose we're looking at something in economics and we're looking at the profits of a company over time. Well, then the slope of the derivative would tell us the change in profits, how much profits are increasing or decreasing at a particular moment in time. As you can imagine, that might be something crucially important for the company to know. Now, this is one kind of graph where we have profits versus time. Another very typical graph would be profits versus price. And in that case, the derivative would tell you how much the profits are increasing or decreasing for a particular price of the item. And that would be enormously important for the company to understand in terms of adjusting the price of the product in order to maximize the profits. Yet another example, in natural populations, we might talk about the population growth. And of course, the slope would tell us how many individuals are being added to the population at that particular moment. At that particular moment in time, what is the increase in terms of number of individuals per day or number of individuals per hour being added to the population? And of course, this curve looks like it's curving up, as populations often do. It's a concave up curve. So it looks like what's happening is more individuals are being added at each successive moment in time. So these are some examples of interpretations that we might give in different contexts to the first derivative.